Hi, welcome to my video on recursive and explicit sequences. Two names we give to certain type of sequences. Recursive sequence. The value of a term cannot be found until the previous term is found. And let's explain. Let's do an example. Notice here I have t1 equals 4, tn equals tn minus 1 plus 2. So notice that we're belonging to the natural numbers, and it says n is greater than 1. Why that? Because we already have 1. So we're looking at n is equal to 2. So if we look at n as 2, then the t of 2 is t2 minus 1 plus 2. So we're putting 2 here and 2 here. So that gives us t2 minus 1 is the t of 1. And the t of 1 is a 4. So we're getting 4 plus 2 is 6. So now we found t2. We use t1 to get t2. Now we're going to do t3. So t3, the t of 3 is n of 3 minus 1 plus 2. 3 minus 1 is 2. That's t2. And t2 is a 6 plus 2 is an 8. And again, to get t4, in this, to get t4, that's a 4, then I have t5. Sorry for that. That's the phone rang, but I disconnected it. Apologize. So we get t of 4 minus 1 plus 2. T of 3 plus 2. T3 is 8 plus 2 is 10. And I can continue on with this, and the sequence is 6, an 8, and a 10. And it continues with that pattern. Notice this pattern, you're adding on 2 each time. So notice you're adding on 2. 6 plus 2 is 8, plus 2 is 10. So let's find the first 3 terms of, again, this is recursive. You cannot find, let's say I want to do T8. I cannot do T8 because 8 gives you a 7. I need term 7 before I can get 8. So we have T1, and again, we're greater than or equal to 2. So we start at 2 or greater than. So n is 2. So T2 is 10. T2 minus 1 minus 3. 10. 2 minus 1 is 1 minus 3. So T1 is 9. So 10 times 9 minus 3. 90 minus 3 is 87. Now that I got T2, now I can get T3. T3 is made up of 10. T3 minus 1 minus 3. Again, I'm using n is 3, so I'm putting 3 in right here and right here in the equation. So 3 minus 1 is 2, and T2 is 87. So 10 times 87 is 870, minus 3 is 867. And we'll do one more. Let's do n is 4. And to get T4, 4 minus 1 is 3. I need T3, which I have. So the T of 4 is 10. 4 minus 1, subtract 3. That's 10. 4 minus 1 is 3. And the third term is right here, 867. PEMDAS, we multiply first. 8670. And subtract 3, 8667. And we can continue. So it's 87, 867, 8667, and we continue on. That's the sequence. But again, it's recursive. What does recursive mean? I cannot find the upper term until I find each of the lower ones in the sequence. And number 2, very similar. We have the f of 1 equals 6. The f of n is twice the f of n minus 1 plus 4. N is greater than 1. We want to find the f of 3. Again, you put n is 3 here. If I put 3 right here, I got to go with 3 minus 1 is 2, but I don't have the f of 2. So I have to do n is 2 first. So the f of 2, 2f 2 minus 1 plus 4. And 2 minus 1 is 1. And the f of 1, which is right here, is a 6. So that's a 12 plus 4 is 16. Now I have the f of 2. I should be able to get the f of 3. So the f of 3 is 2f. N is 3. 3 minus 1 plus 4. 3 minus 1 is 2. And the f of 2, we just found it to be 16. As 32 plus 4 is 36. So this is what we call a recursive sequence. In other words, you can't find T4 until you have T3. You can't find T3 until you have T2, etc., etc. So that's recursive. And the other type of sequence is what we call, explicit. Explicit sequence. The values of any term can be found by substituting the value of n into the equation. So, an example, we have Tn equals 3n plus 2. So, find the value of T1. So, n is 1. So, 3, 1 plus 2. 3 plus 2 is 5. T2, n is 2. 3, 2 plus 2. 6 plus 2 is 8. T6, so 3, 6 plus 2. 18 plus 2, 20. T31, n is 31, so 3, 31 plus 2, so that's a 93 plus 2 is 95. So notice this is explicit, very similar to y equals 3x plus 2. This is very similar to this, and you'll see that is true coming up later, where you say x is equal to 1. So you put a 1 in for x, and you get 3 plus 2 is 5. So that's very similar to what we're doing here. So we can put any n in, and we'll come up with that term. So do some practice. Find the first 4 terms of this sequence. Tn is 4n minus 1. So when let's do n is equal to 1, so the t of 1 is 4, 1 minus 1. 4 minus 1 is 3. And n is 2, so t2, 4 times 2 minus 1, 8 minus 1 is 7. And we're going to do, we want the first 4 terms, so that means n is 1, 2, 3, and then we'll do over here, n is 4. So T3 is 4 times 3 minus 1. 12 minus 1 is 11. And n is 4. N is 4. So T4 is 4. N is 4. So 16 minus 1 is 15. So the first 4 terms of the sequence is 3, 7, 11, 15. That's the first 4. There are more, but that's the first ones. And notice they're going up by 4. 4, add on 4 each time. And this sequence, find the first 3 terms and find the f of 10. For the first 3 terms is when n is 1, that's the first term. So the f of 1 equals n is 1 squared minus 2 times 1. So we're subbing 1 into this equation. And that's we do the exponent first, 1. Okay, I'm doing them one step at a time. So I did the exponent first, and now I'm going to do the multiplication. And then we add left to right. Negative 1 plus 4 is 3. Now I'm going to do the f of 2. F of 2 is 2 squared minus 2. So we're putting 2 here, here, and here. And we work that out. Again, we work the power first, which is a 4. Then I have to multiply next by PEMDAS. 4 minus 4 plus 4. That's a 0 plus 4 is 4. And we do the f of 3. This is n is 2. This is n is 3. And we're doing 3 now. That's the third term. And 3 squared is 9. Negative 2 times 3. Oops. I'm going to, again, work out one part at a time. So I have to do my power first down. Then I got to multiply next, which is 6. And then I add 3 plus 4 is 7. And so the first 3 terms are 3, 4, and 7. There are more if you want more terms, but I only wanted to find the first 3. So what's the f of 10? The f of 10 means that n is 10. F of n, let's put the f of n above this. So the f of 10 is here, the f of n, so that means n is 10. So that means I sub in 10 in the place of n in the equation. And I take my time and work it out. That's, I square first to get 100. Oh, I multiplied that out. I'm going to leave that multiplication till after. So that leaves me, let's go up to here. So it's 100 minus 20 plus 4. So notice I worked the power first to get 100. Then I multiplied after. Remember, we're dealing with P, E, M, D, A, S. We do the powers first, it's 100. We do, P stands for brackets or parentheses, but we have that done. And E stands for exponent, there's 100. That's done. Now we do the multiplication next, gives us the negative 20. Done. Then we add and subtract. 80 plus 4 is 84. So I'm dealing with PEMDAS. P stands for brackets or exponents. And we, like it, PEMDAS is like BEDMAS too. B-E-D-M-A-S, whatever way you learn it. But again, we do the power, multiplication, and then the addition. And that brings us to the end of, there are 2 types of sequences. One is called recursive, where you got to work out the previous term to get the next one. Or you have explicit, where you can work it out what the term is at any, by plugging in the value of n. If you like my video, click on the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.